right. Thank you, everyone, and welcome to the webinar to learn about hybrid and edge software distribution with AWS and JFrog. Before we get started, a quick introduction about me. I'm Anuj Sharma. I'm a senior continuous specialist solution architect at Amazon Web Services. I'm based out of Seattle and have an industry experience of around 15 plus years in application and infrastructure development. In my day-to-day life, I love to build things on AWS. In the webinar today, I'm joined with Sven, who is a developer advocate at JFrog. Sven, would you like to introduce yourself?
Yes, hello. First of all, thank you for the introduction. And yes, my name is Sven, and I'm based in Germany. So for me, the day is already done. So just mention it. And I'm working for JFrog as developer advocate, focusing here on DevSecOps. And I'm happy to share all the insights about distribution based on AWS and JFrog. So thanks, and back to you.
Let's before we go on further, let's take a deeper look at what topics we will cover today. In the first section, we will look at what is AWS perspective on edge and compute and hybrid computing, and why is it relevant to the customers. And then we will see what are the 3 AWS edge infrastructure services which the customers can benefit from, and then dive into each of these services along with the use cases. We will then see what are the challenges of software distribution and what are the distribution acceleration options that we have available with JFrog. And in the end, talk about solutions for hybrid and cloud computing. All right. So just to level set, let's first define what is edge. AWS thinks about edge as providing infrastructure and software that moves data processing and analysis as close to the end users. In order to achieve this outcome, we may need to deploy AWS managed hardware and software out of AWS's data center into customer-owned devices or networks, or something even closer to customers like telecommunications providers' own location. With the scale and innovation that cloud has unlocked the customer to create unique set of applications, there has been a vertical of applications which drives the requirement for improved edge performance for data processing, analytics, storage, and machine learning. With these unique cases unlocked, cloud developers are discovering the benefits of doing some computing and analytics and closer to the end users outside of the cloud within set of devices which offer the same unique features as cloud or gives similar advantages as those in cloud. There have been customer use cases where they cannot either upload the data to the cloud, example, because of lack of connectivity, like in a mine or in an oil rig, or they cannot afford to upload data to the cloud because your jet engines or manufacturing line produces terabytes of data every hour, or you're not allowed to upload data to the cloud because your devices operate in a regulated environment. Additionally, many customers not only rely on cloud for processing, analytics, storage, and machine learning, but they also need some processing like machine learning inference really close to the end users in order to deliver fast, intelligent, and real-time responsiveness and reduce the amount of data that is getting transferred over the wire. For example, smart home devices like vacuum cleaners need to be able to see obstacles in real time and react to it. Or self-driving cars need to be able to ingest and process information from multitude of sensors in real time without having to connect back to the cloud. Applications like these are driving requirements for improved performance at edge of the cloud. Back in 2019, AWS launched 3 new infrastructure services. They are AWS Outposts, AWS Local Zones, and AWS Wavelength. In today's session, we will take a closer look at each of these 3 services and which services would you choose depending on your specific use case. On a very high level, AWS Outposts provides AWS managed hardware and services on-premise. AWS Local Zones extend AWS regions and services by providing infrastructure deployment and services in large metro areas such as Los Angeles, and now even available in preview in Boston, Houston, and Miami. Wavelength extends AWS regions and services to telecommunication service providers, data centers at the edge of 5G network. These three services from AWS provides customers the necessary infrastructure to run the application, and JFrog platform complements these services by providing a one-stop vehicle to deliver the software applications to these three services. Now let's take a deeper look on each of these services. First up, AWS local zones. Now, AWS local zones are a new type of AWS infrastructure deployment that places the compute, storage, databases, and other select services closer to large population, industry, and IT centers where no AWS region exists today. With local zones, you can easily run a latency-sensitive portion of your applications really close to the end users and resources in a specific geography, delivering single-digit millisecond latency. With local zones, or essentially local zones are an extension of AWS region where you can run your latency-sensitive application using AWS services. Each local zone are managed and supported by AWS, bringing all the scalability and security benefits of the cloud. Let's see the use cases around AWS local zones. Firstly, customers can run latency-sensitive workloads such as live production, video editing, and graphic-intensive virtual workstations for artists in geographic proximity to local zones, thereby kind of accelerating content creation by getting rid of latency limitations and constraints while improving security and operational efficiency. You can deploy latency-sensitive game servers in local zones to run real-time multiplayer game sessions and maintain a reliable gameplay experience. With local zones, you can easily host and train models continuously for high performance, low latency inferencing, and you can easily work with your data, experiment with algorithms, and visualize the outputs faster. Customers can even live stream video content with a single digit millisecond latency and high fidelity to end users and perform computation and analysis of the video content really close to the event. With local zones, you can support AR, VR applications by performing computation and analysis close to your end users, effectively reducing the motion to photon latencies to the less than 20-second milli benchmark needed to offer a realistic customer experience. All right, next up, AWS Wavelength. AWS Wavelength brings AWS services to the edge of 5G network, minimizing the latency to connect to an application from 5G connected devices. Application traffic can reach application servers running in a wavelength zone. AWS compute and storage services such as EC2, EKS, ECS, etc. are embedded within telecommunication providers' data center at the edge of the 5G network, and customers can use them without leaving the telco provider's network. This reduces the extra hop to the internet, and which can result into tens of milliseconds, preventing customers to take the full advantage of bandwidth and latency advancements of 5G. Wavelength provides high bandwidth, secure connection to AWS region, allowing your applications to seamlessly connect to a full range of services within the region. Developers working on Wavelength get the benefits like elasticity, availability, and pay-as-you-go pricing that they have come to expect. With Wavelength, you can essentially start small and scale as your grow needs without actually worrying or managing physical hardware and maximizing the utilization of the purchase capacity. Now let's see some of the use cases around Wavelength. AI ML driven video analytics and image processing, image matching solutions helps doctor to speed up diagnosis of the observed conditions, such as recognizing polyps during colonoscopies. The image or video streams from medical devices are processed in the wavelength zone, and the response is returned to the medical device for the surgeon to use. Connected or cellular vehicle to everything is an increasingly important platform for enabling intelligent driving, real-time HD maps, road safety, and even more. Low latency across compute infrastructure needed to run data processing and analytics on wavelength enables real-time monitoring of data from sensors for secure connectivity, in-car telemetrics, and autonomous driving. Industrial automation applications use ML inference at the edge to analyze images and videos videos to detect quality issues on fast-moving assembly lines and trigger actions to remediate the problems. Wavelength essentially enables these applications to be realized without having to use expensive GPU-based servers on the factory floors. Real-time game server streaming depends on low latency in order to preserve the user experience. With wavelength, the most demanding games can be made available on the end devices that have limited processing power by streaming those games from game servers in wavelength zone. Wavelength provides ultra-low latency needed to live stream high resolution video and high fidelity audio, as well as embed interactive experiences into live video streams. Additionally, real-time video analytics provide the ability to generate real-time stats that can enhance the live stream experiences. All right, let's talk about AWS Outposts. Now, AWS Outpost delivers AWS design infrastructure to customers' data centers or on-premise facilities. You can run a wide range of AWS services such as S3, EC2, EBS, EKS, RDS, or even EMR on Outpost on-premise. You can seamlessly extend your VPC and connect to a broad range of services available in the local AWS region. You can use the same AWS APIs, tools, and secure controls to run, manage, and secure your application on-premise just as you would do it in cloud. As Outpost is fully managed, AWS will deliver, install, and maintain the hardware infrastructure. Services and softwares will be patched and updated as a part of the regional operation. JFrog platform has been verified as an Outpost-ready product that integrates with Outpost deployments that has been tested, certified, and follows AWS security and architecture best practices. Let's see some of the use cases around Outposts. Now, we are seeing an increasing evolution where customers have a continuum of applications that are either easier or hard to migrate to the cloud. In this continuum, workloads on the left-hand sides are easy to migrate to the cloud and often include everything from back-office applications to SaaS applications delivered to the mobile devices. In the right-hand side, essentially the right-hand side of the workloads are harder to migrate, whether that's because of the low latency or local data processing needs for the workloads that may need to remain on the factory floors for automated operations in manufacturing, something like real-time medical imaging or content and media streaming. And somewhere in between, there is in the middle, we have workloads that could either use cloud or on-premise solution, depending on what's actually available in that specific AWS region. This type of situation usually involves data that needs to remain in particular country or state for regulatory, contractual, or information security reasons. At AWS, we think about app continuum. We we also need AWS infrastructure and services continuum to help you run your applications wherever you need. Starting off with AWS regions that serves most of the customer's use case, and then extending out to the farthest part of the edge with IoT and disconnected environments. We are also building out services in the middle tier where customers need AWS infrastructure and services on-premise in large metro areas near end users and at the edge of 5G network to reach mobile devices. When we look across this continuum, AWS region serves the use cases for most of our customers. But for the middle tier, Outposts provides AWS infrastructure and services in customers' on-premise environment and is the building block for AWS local zones that bring services closer to the end users, and AWS Wavelength that delivers AWS services at the edge of 5G networks. And for workloads that need to run in local in remote locations where there is a lack of connectivity or lack of consistent network connectivity and no on-premise availability, there is always AWS IoT Greengrass and FreeRTOS and of course the Snow family of devices for rugged environments. There are three main reasons that dictate why applications must remain on-premise. Firstly, some of your business-critical applications are sensitive to latency and variability in latency. You need applications to run on-premise to support either equipment and processes that are sensitive to compute latency. In order to ensure smooth and predictable operations or even to provide superior experience to the end users. Now, you have adopted AWS Cloud for centralized operations, but you find you need to run compute, graphics, or storage intensive workloads on-premise to execute interactive workloads such as AR/VR design or visualizations. These may be the workloads that span across host and storage system. Example includes factory floors and real-time diagnosis and content media streaming. Now, secondly, there has been an exponential increase in the data that is being generated by users and end devices, and data integrity is a key concern in locations where bandwidth is limited or constrained. We have data-intensive workloads that collect and process hundreds and terabytes of data in a day, and transmitting these large volume of data to the cloud will be wasteful and expensive. It would be good to process this data locally and respond to real-time events and to have a better control over analyzing, backing up, and restoring that data. At the same time, you can always leverage cloud services such as AI/ML framework or analytics as they do in the cloud for data visualizations and in cloud. And you can use services like RDS to store the data locally and transfer it later onto the cloud. Applications that process this data to drive better visualization or business insights need to run on-premise as close to the data sources and the end devices. And thirdly, you may be operating in a geographical area where regulations dictate the data and infrastructure reside in a specific country. You may be doing business with public sector entities where contracts actually specify where the application needs to be deployed. Lastly, your enterprise may be in the process of migrating to cloud, but they're not yet because of InfoSec or any other organizational reasons. So there are also challenges that we have heard from customers, such as lengthy cycles to procure, provision, deploy, and maintain on-premise infrastructure. We also heard from customers and specifically developers that they want to use the same APIs when it comes for doing the development against cloud and on-premise. And these challenges in turn lead to poor ROL for technology investments and in turn slower down the business growth. So if I had to summarize what does Outpost provides, it essentially provides the same reliable, secure, and high-performance infrastructure as AWS Cloud. It provides the same operational consistency, and it provides the same services, APIs, and tools, and the security controls that provide you the same pace and innovation as you do it in cloud. Now, to recap, there are three AWS services that we talked about, mainly Outposts, local zones, and Wavelength, which helps customers run the application at edge and in hybrid use cases. Now I would like to invite Sven to dive deep onto how a JFrog platform complements these services by providing one-stop pane of glass to deliver the applications across these three services seamlessly. Over to you, Sven.
Okay, thank you very much. And yeah, we heard a lot about this infrastructure and how to scale globally. My first task is now to learn how to switch the slides, And yes, done. So we're switching now to another layer. So we have now the huge global infrastructure going up to the edge, and we heard a few words, especially the word edge, for example. So edge is used in different contexts. So we will have there some clarifications if we are talking about edge in our world, in their world, and so on. But don't worry, we are switching now to a more the view of a software developer if we are talking about, for example, the software delivery lifecycle. So first of all, if we are thinking about the global challenge that is happening here, so we have, or we assume that the amount of applications will increase. So I think this is, we're not discussing if this is increasing, we can discuss how much it's increasing, but we're expecting it will increase. So this will definitely push more load on our infrastructure. The next is, if you are looking at the typical software development, the amount of dependencies is increasing. Just an example. If you start working in a monolith, you have some dependency. In the old days, you were just copying a few binaries together, and you're building your web archive or whatever, and then these binaries will stay there for ages. But slowly, you're increasing the frequency of changing dependencies. We want to be cutting edge. We want to get the latest features, and we are having more and more complex use cases. We are building more complex tech stacks to get more convenience during the development cycle, to have more complex use cases, and so on. And everything together leads to a bigger amount or a huge amount of dependencies. So instead of creating a PDF library, we are adding a dependency. So dependencies are the biggest part of the full stack. So looking at an application, the amount between dependencies on writing code by yourself, dependencies are way more lines of code you are adding than compared to writing your stuff by yourself. Going to the operating system, you're configuring it, and the rest are binaries you are taking somewhere and using for operation. So we are talking about huge composition of dependencies, then Docker, Helm charts, whatever. So this is one thing. The other thing is we are start splitting up all this stuff in a way that we want to go from monolith more to microservice. Microservice means we have now a big split, and every microservice is grabbing dependencies, but every microservice should be deployed very fast. So the deployment frequency will grow over the time tremendously because we want to be fluid. We want to have some kind of liquid software. So the version is not available over a year or a month. We are talking about deployments per day, per hour, and this in a zoo of microservices. So this is increasing as well. And we're expecting that we have more and more intelligent and good hardware, talking about mobile interfaces, talking about this IoT stuff, and so on, what we heard before. So everything together is not increasing linear. So we have different dimensions, and this will just blow up the need for infrastructure, for shifting binaries, for performance as well. So this is a basic thing. And what I mentioned here is just, if you're looking at a global or local thing, if you're talking about a regular Java process or whatever, so a program, you have some binaries, you're grabbing these dependencies, and then you're building the new composition, and this must be stored something. So the consumer is requesting one part, but in the end, we have a network of dependencies. We have a network of stuff that should be grabbed immediately as fast as possible. So we have this huge cascade of requests. And looking at this one, we can't assume, or we can't expect that everything will be in a local network. It will be somewhere in the world. It will be distributed. It will be sometimes air-gapped. So how to deal with this one? And the other thing is talking about the size. We're not talking about as a developer that's just building jars, we're talking about a few megabytes. But in the end, we're taking this jar, we are wrapping it in an operating system. We are pushing it with a Docker image somewhere. So we have this component artifacts. Even if you're talking about the Docker layer and we have these single layers, every layer itself, even if this is immutable, it's a bigger piece. But there is one thing I just mentioned, immutability is one of the good things. And talking about security, if we have a huge amount of dependencies that we are grabbing from all over the world or transferring, security is one part. So checking dependencies against known vulnerabilities is one thing that you should have in mind. If you want to know more about this one, what are the low-hanging fruits at this point, check out my YouTube channel. I have some talks about this one. But if we have now this scalability challenge, so how to deal with all these different directions where the computing power is needed, the bandwidth is needed, the storage is needed. So what are the solutions for us in practical life? And having in mind that we are not only talking about everything that's running on cloud, we have, for example, high security networks that are on-prem, that has no connection to the internet. You have to deal with this hybrid solutions, or there are some regulations in some countries that you can't use all infrastructure that is available in some parts of the world. In some other parts, it's not completely available. So you have to deal with this. So what scalability mechanisms you have, or what are the possible things that you can scale? So one thing could be you could build a custom solution. So we have from AWS the infrastructure, and you could start thinking about, I'm building some solution, I'm pushing some replications here and there, I'm buying more hardware, I'm consuming more hardware in the cloud, so more CPU power. So this is something you could do, but this is not trivial and this is not an easy task. So, but this is one thing. Then there's another thing that is called peer-to-peer technologies. We know peer-to-peer sometimes from private usage, but peer-to-peer is something to scale in some way of distributing stuff, but it will have a different behavior in terms of resilience, scalability, and the difference between upload and download, so consuming or pushing to the network, how to deal with replications and all this stuff. So this is another technology if you're thinking about how to deal or how to use peer-to-peer technologies in the cloud, but as well as on-prem or in a hybrid environment if you have to connect those worlds. And the last thing I want to highlight is here the practical usage of these content delivery networks. So we have different ways to scale, but there is no one size fits all. So we have to choose the best for our needs at the right position. So mostly it's not choosing one and it's good for everything. So you have to build an architecture out of it so that you can scale exactly in a way you need at the point that fits to your project. So talking about distributing by yourself, it depends a little bit on the things you can distribute and how you're dealing with these dependencies. So one thing is, for example, if you have repositories and you want to replicate repositories and you want to do it with your private artifacts, for example, or you want to grab something from external and push it to an internal part of the company that are distributed over the world, different developer centers or whatever, you need some infrastructure that you get from AWS, but on top of it, you need this logical structure. And thinking about distributing repositories, an example would be a Maven repository. It is easy because we have this group ID, artifact ID, binary is immutable, and you can just merge different repositories. Sometimes not so trivial. If you're thinking about Debian repositories, for example, every Debian repository has this package, the tar.gz, and then you need some logic to merge different repositories to replicate them or to hold them in your infrastructure. So understanding different packet managers is one of the key elements if you want to share binaries efficient on this huge scalable infrastructure we are getting from AWS, or if you want to do it on-prem, you need the understanding of the package managers. I just want to highlight a little bit the landscape we were talking about, so that you a little bit more familiar with the topics or with the keywords I'm using. So we have Artifactory, that is a binary, the logical part of this binary storage. It could be high available, it could be distributed, whatever. So it's this logical part. It's understanding the package managers, holding the binaries. And now what's going on? What we need, for example, is some kind of access management, role-based access management. So not everybody is allowed to get every binary, and this should be available everywhere in the network. You don't want to configure it on every node. You would have it everywhere in the network. So you need something that is able to speak to all logical components to make sure that your defined rules and roles are active everywhere. We have this X-ray. X-ray is a possibility to scan all binaries. If you're grabbing binaries, if you're sharing binaries, you want to make sure that they are secure, that you don't have vulnerabilities, you don't have compliance issues, and so on. This is a logical layer on top of this sharing securely binaries to make sure that binaries are really unmodified switching locations. There's this distribution part, the logic brain that is coordinating what is somewhere on top of the infrastructure, the logical nodes. You have some dashboarding and monitoring so that you're aware that your logical infrastructure on top of the AWS infrastructure is running well. And additionally, we have some CI pipeline, but we want to focus now on how to distribute these binaries and what are the benefits here at this point. So for this, we are defining something like a release bundle. A release bundle is an immutable bill of materials. It could be a composite of different binaries from different technologies, Debian binaries, Java binary, and so on and so on. So this in composition is immutable. It's a release bundle. So this is an atomic unit we want to share. We have to make sure that this is secured with fingerprints, for example, so that you can make sure that it's not modified over the way, and so on. X-ray is scanning this stuff. And again, we want to make sure that the role-based access is everywhere. The next thing is we are talking from edge nodes as well. Here the term is slightly different. So edge is here not the consuming unit, the unit that is producing the binary or consuming the binary. In our world, an edge node, a JFrog edge node, is more or less a read-only repository that is able to have secured communication to the main repository, the Artifactory repository, and is aware of the architecture so that there is a smart caching, a smart replication available. So we have a patent pending. So then maybe we can talk a little bit more about this one, but everything is about how to optimize a network communication and so on. And they are tuned for scaling. How this is done, if you're distributing binaries over different edges and different positions, what we need is some logical structure. And again, we're talking more or less about building some immutable composition of binaries and then transaction behavior. Just as a short overview how it's done, because the UTID for you in the web UI is quite easy. If it is just activated, you have to say this one distribute the checkbox. Well, that's not so complicated, but how this is, or what's going on under the hood. So you're creating a release bundle snapshot. So you say, this is the composition I want to share somewhere. And then you're fetching from Artifactory all these parts to make this release bundle. So to make sure that this bundle and all binaries are existing and available. If you have this one, you would distribute to edge nodes in terms of talking to the distribution. So I want to start with the distribution. So the distribution node is aware of the logical nodes. So if you have the monitoring from AWS, you know the nodes are running, the network connection is right, and all this stuff. But the distribution on top is more or less with mission control, optimizing or checking if the logic points, the service that's running is running well, if the utilization is good, and so on. You will get some tricks. So by distributing to the edge nodes, it means that we are discovering what edge nodes are available, how to get to them. So what is in APAC, what is in Europe, or whatever. And the next step would be that we say we want to distribute it, and we have to say to the Artifactory, because Artifactory is a leading unit, because they are the binaries, and then say to Artifactory, okay, please start this sharing process, and we'll open the transaction and start sharing this stuff to the edge nodes. So you have different edge nodes somewhere in the world. It will take different time. So you are starting a logical transaction, so indirectly, but you just say distribute. And then if everything is done, then we are closing the transaction and you are sure that the binaries are everywhere where you want to have them. So you don't have to deal with in Asia, but not in Europe, whatever. So, and here again, this is not only working inside the AWS infrastructure, it's working on the prem as well. So we are building hybrid solutions. This is one of the big things here because we have no barriers at this point. So this is good if you're replicating repositories and pushing your binaries to consumers because you want to develop somewhere or whatever. The next thing is if you need some burst downloads. So you have a bunch of consuming nodes, edge nodes, for example, that need this binary, a bunch of driving cars in an area that want to grab it, or some CPU units that need this new binary to run the new algorithm. So in these local networks, in these local areas, you need this peer-to-peer technology, because here you're pushing it once, it will be replicated, and then a lot of consumers can download it fast with this developed latency. So how this looks like, normally, if you would say, I need now a bunch of Docker images of the same Docker image in different locations, or not locations, different consumers, you would ask Artifactory. This could be a bottleneck depending on the amount of requests at the same time. But what you could do, you can install this peer networks. It's managed by Artifactory. Artifactory is pushing it to the peer-to-peer nodes, and then you're consuming from the peer-to-peer nodes. It's exactly what we know from regular peer-to-peer networks, but it's under your control. It could be in the cloud, it could be on-prem, it could be on both at the same time. So this is if you have to deal with burst downloads. So, the thing here is that we have secured proprietary peer-to-peer network, and it's really optimized for the enterprise usage. And the whole organization for content lookup discovery is done by Artifactory because there is information already, what's existing, what version, and so on. So the good thing is that even the peer-to-peer nodes respect the role-based access. So it means what you defined in your local Artifactory will be present on every peer-to-peer node. That's it. So, for you, there's nothing to say. Just say, I want to share. That's it. Then it's running. Okay. The last thing at this point is, if you're distributing in your own network or the binaries and repositories and share internally because you don't want to push it to the outside, then handling the burst downloads in your infrastructure on your local zones. Then the next thing is if you want to distribute it to the world, you produce something like an SDK, a drive, or whatever, and you want to push it all over the world. What do you need? Content delivery distribution. This we integrate as well. So using the AWS mechanics to share it everywhere. And here again, we have the role-based access here implemented. So this is a good thing. So even there, something using our own definitions, and you have something like authentication, authorization, and this links, so you can create these links without login, so that you can share this one as well. So altogether means a solution for you is mostly not just one thing, and that's it, just peer-to-peer or this one. If you have a more complex environment, if you have a more complex scenario you want to scale, there is an architecture that is based on the possibilities that AWS gives you to scale in the infrastructure world, as well to scale on the logical part in the JFrog world, and both fit perfectly together because we can now share this experience. We can scale at different directions because, as I mentioned in the beginning, we have to deal with huge amount of applications, huge amount of frequency of grabbing dependencies, sharing dependencies, and so on and so on. So this is one of the things. This is running worldwide, everywhere where you need it. There is a solution. If you are on a drilling station far away in the ocean, there is a possible architecture to help you at this point. And one thing I want to share here is that at AWS Marketplace, you can just go there and say, yes, I want to have it. And, well, that is one thing. I think I have now one thing to mention. Well, there's a conference, and we're talking a lot about this stuff as well, and this is called JFrog's Warm-Up. And it will be an online conference, surprise, surprise, and it will be 25th or 27th of May in America, and we have an EMEA version for a different time zone in June 1 to the 3rd of June. So we have hands-on training, sessions, use cases, and so on. So it's worth to have a look there to see what we are doing. If you want to have a little more ideas about how to deal with the dependencies and security stuff, check out the JFrog channel, or I would appreciate to have you as my new subscriber on the JFrog channel on YouTube, as well as on my private one, because we're talking a lot about this additional stuff, because distributing is one thing, making it secure is an additional thing. And I think slowly, I want to say, Anuj, we are ready for Q&A. What do you think?
Yep, absolutely. Happy to answer any questions.
So it's time. Please write all your questions. We are happy to give some answers. So let's see. So I have here, what is your recommendation of transmitting and deploying builds of packages deployed in the DevOps pipeline from cloud to on-prem? Okay, I think this is you need a multi-dimensional answer here, I would say. So Anuj, you want to give the way for the cloud part to this question?
Yeah, absolutely. So again, there could be like different kind of architectures that can be designed for this specific scenario. One I can think of is like enable caching of these artifacts between on-premise and cloud, right? So you assume that you have Docker images as an example, which are produced from a pipeline in cloud. You can set up a virtual repository which can cache that that produced Docker image on-premise. And so when you call it from on-premise and set up something like split DNS, so that if the request is originating from on-premise, it goes to the cached version, and Artifactory essentially pulls up from the server version. There are different kind of setups also that we can make, but it depends on the use case. I don't think having Outposts will be a better solution in this case, only for the purpose of artifact caching. But yeah, that is one way to look at. Basically cache your artifacts either using S3 replication or using Artifactory repository caching or something similar. Any other thoughts, Sven?
Well, I would say if you're completely in the cloud, there is a good solution. And if you have to go on-prem somewhere, you could think about the distribution. So you have your repository, you're pushing it to the edge node somewhere. If you need a high consumer, this huge download, then thinking about scaling with P2P or whatever architecture inside your on-prem environment. But yeah, that's it. And the worst case would be air-gapped. So you're just exporting a repository, taking it to your high security network over the wire, not over the wire, but it, and pushing it in. But this would be, I think, really the worst case. So I hope you could give you at least a little bit an answer. Otherwise, let us know in the Q&A.
Yeah.
So the next one would be, in which JFrog product package the edge node feature is included? A good question. I have to check if it is Enterprise Plus. I just have to check it. But I can search until Anuj is giving an answer to something different. I think there's another question. I can search for the link and try to give you the direct documentation here. So I have to check it. I don't have everything in mind regarding the sales part. Okay. So, Anuj?
Yes, I do see one more coming up, which is We don't have 5G available yet widely in all the parts of the country. Can I still use wavelength zones over 4G or LTE connected devices? Yes, you can indeed. Applications which are running, let's say, on 5G or LTE mobile devices and devices which are connected to 4G or LTE network can indeed access your application servers on wavelength zone. Thereby, you can simply benefit from having the compute infrastructure which is co-located within the mobile network. Yep, I hope that answers. And let us know in the Q&A section if any other follow-ups regarding this.
Okay, so just going back to Sven Fischer, the question you had, I need some time to make sure if it is really Enterprise or Enterprise Plus. So I will ping you via email and send you the information with the right link there as well. So sorry for this, but I'm not sales, I'm technical guy, so sorry. The next one would be, we have something, let me see. So, oh, yeah, there's a question how to deal with high security networks, so with air gap networks. Well, I mentioned it indirectly. So I know it from some big companies or governmental environments that they have this need for highly isolated networks. So really there is no connection to the network. It's really an isolated network, no physical connection. And you could have everything from JFrog there as well, even X-rays or security scanning. So what it is mostly the case is you have something that has connection to the internet. You're replicating the stuff. And what you could do for repositories, for example, you're just exporting a repository, shifting it over, importing this repository. There's one way. With X-ray, with the security database, it's the same. So if you have an update on X-ray and push to your instance, you can export this database, get it over the wire, import it so that you have this vulnerability and compliance scanning on actual state as well inside your closed on-prem environment. So that is the way to go if you really have this hard cut between these networks. But it's possible with all products. So pipelines, X-ray, and everything. So, okay. Any other question?
I see there is one more. Do we have time for one or two more?
Yeah, sure, we have some time.
Okay, awesome. So I see one more, which is I need to pre-process streaming data before it actually reaches backend servers in AWS. Which out of Outposts, Wavelength, and local zones should I select? So frankly speaking, the answer to this really depends on the use cases and the source of the application which is generating that data. As an example, if the source application is really sitting on-prem, selecting Outposts will give you a better result, because in this way, your both the producer application and the processor application, which can be an Outpost, will be co-located. Now, let's say if your application is connected to 5G network, in that case, for sure, Wavelength could give you better results. And let's say if the source is within one of the local zones which are currently available or in the preview phase, that could give you a favorable cost. And lastly, I assume that something like streaming application can also mean click streams. So in that case, if it is a web application which is producing click streams, if that is the case, then probably Lambda at edge will give you a better throughput and better answer to that. I hope that answers. And sorry for being lengthy, but it really depends on the use case and the source of the application here.
Okay. Well, any more questions? I can't see something. So if you have any question, just ask now. The last time. Otherwise, if you're have a question tomorrow, feel free to connect to us. So you have Anuj coordinates, you have my coordinates on Twitter at Sven Ruppert, or by email, whatever. So I think you can connect to us. Feel free to ask if you have any more questions. Don't be shy. Even if it is tomorrow or in a few weeks, have an eye on our upcoming webinars, because we are covering a lot of more topics. So go to jfrog.com/webinars, I think it's the link. Then you can see what's going on there. And we have workshops. So if you want to try all this stuff by yourself, ask for a workshop, and we have a few in pipeline. So this for sure. Otherwise, if there's no, I will check once if there is one more question. But I think I can't see anymore. Then I would say, for me at least, it was a long day, and it was a pleasure to have you here inside this webinar and to listen to us. And any last words from you, Anuj?
Thank you, everyone, for coming. It was really good talking about these technologies, and really cool and evolving technologies. Hope that can solve your specific use cases. And feel free to reach me out or Sven out if you have any further questions or follow-up. Happy to answer that.
Okay. So thanks very much.
Perfect.
And I will get back to Naha.
Thank you, Anuj, and thank you, Sven. Just shortly, our apologies for the small audio issues we had in the beginning. Thank you for your patience while we resolved it. As we mentioned, you will also receive the recording of the webinar tomorrow. If you have any other questions, please feel free to reach out to Sven or Anuj directly. That is it from us for today. We hope to hear from you soon. Thank you, everyone, and have a great day. Goodbye.
Bye.
Bye, everyone.